and sharing my screen. And that's not where I want to be. Give me a minute. Today we're just reviewing last class. We finished inequalities. We looked at those absolute value inequalities. Homework 1.5 was to have been done. That was the one with all of the different ways of solving quadratic equations. 1.6 is on all of those different types of equations, ones with exponents higher than 2, ones that are quadratic in nature, radical equations, and ones with rational exponents, and absolute value equations. 1.7 are the inequalities, the compound inequalities, the absolute value inequalities. And then that problem set 2, I think it actually is called problem set 2 plus, is practice for that test that, if I remember correctly, last class we decided we'd open it a little bit early because some people said they wanted the weekend in which to do it. So it should be available from Friday morning till end of the day. I think it wasn't supposed to open till Tuesday, so we decided it would be open till end of the day Wednesday. All I have planned to do today is to answer questions that you folks might have on some of the homeworks, if there are any, and to go through one of those problem sets with you, one of those practice tests. So I guess first question I have for you before we start looking at that practice test is, does anybody want to go over any of the homework questions? Have I waited long enough? Can I go on the assumption that there are no homework questions right now? If not, should we start looking at a copy of that practice test?
Yeah, I would like that.
Okay, great. I'm going to take this and make it big screen width so that there's plenty of room in which to do the work. I don't know if you can remember way back when to when we first started looking at chapter 1. We started by looking at the idea that the graph of an equation is the set of, in 2 variables, is the set of all the points that satisfy the equation. We had said one way of finding the graph of an equation is to make a table of values. And so over here, we've got a table of x values. We want to find the corresponding y values and then use those ordered pairs to graph it. In my labs, in order to graph it, you've probably noticed what you end up doing is picking a lot of times that right graph, doing a multiple choice type of thing. So let's go through and start making this table of values. When I make this table of values, we're going to substitute x into y using that equation. Oh dear. Y. Uh-oh. Give me a minute. The touch screen is not liking that stylus. Let me see if it works with the other one. Using y equals x cubed plus 2. So if x is -3, y would be -3 cubed plus 2. -3 to the third is -27 plus 2 would give me -29. And then when x is -2, -2 cubed plus 2 would be -8 plus 2, or -6. When x is -1, -1 cubed plus 2, well, -1 to the third is -1, plus 2 is 1. When x is 0, 0 to the third plus 2 would be just 0 plus 2, or 2. When x is 1, y would be 1 to the third plus 2. 1 to the third is 1. Adding the 2 gives me 3. When x is 2, y is 2 to the third plus 2. 2 to the third is 8 plus 2 would give me 10. And lastly, when x is 3, y is 3 to the third plus 2, which would be 27 plus 2. Or, I'm sorry, this one shouldn't be negative 29. That should be negative 25. Guys, yell at me if I make a careless mistake. Or 29. Let's make that negative 25. What's your signs? And so now to pick the right graph, when x is negative, y is negative. So when x is negative, y should be negative. That rules out A and C. So my options are B or D. Now, when you're doing this in my labs, you should be able to click on it and make it larger. But as I compare those two, what I want to focus on is when x is 0, that's my y-intercept. And do you see how over here when x is 0, y is a positive 2? So I should cross the x-axis. My y-intercept should be positive, giving me that D is the correct choice. Does anybody have any questions on that one? Not hearing any. Next, we've got one of those rational equations where we're solving an equation that's full of variables. I know when we had a quiz that involved this, some people worked very hard working with the fractions. When we looked at these in class, we had said that it's probably easier to clear the fractions. We can clear the fractions again because there's this equal sign in the middle, so we can do the same thing to both sides of the equation. So what I want to do first is find the lowest common denominator. I've got denominators of 2, 6, and 3. The smallest multiple of all of those would be 6. And now that I've got that common denominator, I'm going to take both sides of that equation and multiply them by 6. This gets to be a little tedious writing because on the left, we need to distribute, giving me 6. I'm going to put that over 1 times 3x over 2 minus 6 times x equals, on the other side, when I distribute, I get 6 over 1 times x over 6 minus 6 over 1 times 5 over 3. And for just a half a second, that looks much more involved than our original equation. But if we chose the right common denominator, each of these denominators should go into 6. So reducing 2 goes into 6 3 times. 3 times 3x is 9x. Minus here, we just have 6x. On the other side, 6 divides out with the 6, leaving me with x, minus 3 divides into 6 twice, so minus 2 times 5 would be minus 10. And now we've got a much simpler equation to solve. Is everybody comfortable with that multiplying through by that common denominator to clear the fractions? Any questions? So now we've just got a first degree equation to solve. 9x minus 6x is 3x equals x minus 10. We want to bring all of the x's to the same side by either adding negative x or subtracting x from both sides. Gives me 2x equals negative 10. And then to solve for x, we want a coefficient of 1. So dividing both sides by 2, we get x equals negative 5. Over here, when I substitute back in, negative 5 should not give me a 0 in the denominator, so that should check. Did you folks want to go through and do a check together? Let's go ahead and check it. I'm going to shrink it just a little bit. We've got 3x over 2 minus x equals x over 6 minus 5 over 3. Let's see, that would be 3 times negative 5 over 2 minus negative 5. So let's see, that would be negative 15 halves plus 5 would be plus 10 halves. So that gives me negative 5 halves. On the other side, what? On the other side, I have negative 5 over 6 minus 5 over 3, which would give me negative 5 over 6 minus 10 over 6, which gives me negative 15 over 6, which would reduce to negative 5 halves. And so it checks. That one okay? Not hearing any questions, let's look at number 3. It says the following rational equation has denominators that contain variables. First part asks, what are the value or values of the variable that makes the denominator 0? Remember we had said with a rational equation where there's a variable in the denominator, we've got to find what values to exclude, and the values that we would exclude are the values that make that denominator 0. So I'm going to set each denominator equal to 0. First one is x plus 3. Setting that to 0, when I subtract 3 from both sides, I get negative 3. Next one, if I take x minus 5 and set it equal to 0, adding 5 to both sides, I get x equals 5. Now if I look at that factored one, x plus 3 times x minus 5, in order for that to equal 0, each factor would be 0. And we've considered those already. So the values that make the denominator 0 would be negative 3 and 5. Is everybody okay there?
Yes.
Then to solve this equation, to find the solution set, what we want to do is we want to, just like when we had numeric denominators, find the least common denominator. And let's see, for my least common denominator, from the first fraction, I need a factor of x plus 3. From the second denominator, I need a factor of x minus 5. From the third fraction, I have both of those factors. And so that'll be my common denominator. So I'm going to be lazy. And where this equation was first written, I'm going to go around both sides and big parentheses and then multiply both sides by that common denominator. And again, it's easiest to see if you put that over 1. On the left-hand side, you need to distribute. And so that gets to be a little bit of a pain to write. Distributing gives me x plus 3 times x minus 5 times 2 over x plus 3, plus the other one would give me x plus 3 times x minus 5 times 4 over x minus 5. And then on the other side, both factors would cancel, and all I'd have left is 32. To simplify what's on the left, the x plus 3's would cancel, and I have 2 times x minus 5. With the second product, the x minus 5's would cancel, and I have 4 times x plus 3, and that's supposed to equal 32. And again, if we choose that right common denominator, we can change it into an equivalent fraction without denominators, which should be much easier to solve. Again, on the quiz on this, some people kind of took a totally different approach. Does this make sense to everybody? Is everybody okay? So I'm going to slide it over to give myself a little bit more room to work. Distributing again gives me 2x minus 10 plus 4x plus 12 equals 32. Combining like terms would give me 6x plus 2 equals 32. Then solving, we'll subtract 2 from both sides, and we'll get 6x equals 30. And dividing, we'll get x equals 5. Now, usually with these rational equations, it's important that you do a check. But I think this time we can be a little lazy. Is everybody okay if I shrink the screen for a minute? To go back to the question. We've got as a solution set x equals 5. But way up here, we said that 5 gives us a 0 in the denominator. And so our solution x equals 5 won't work because it'll give us a 0 in the denominator. And so this equation has no solutions. Its solution set is the empty set. How's that one? Any questions? Can I go on to the next? Wow, you guys are quiet this morning. Is this helpful or am I boring you to tears?
No, that's helpful, for sure.
All right. Let me know when you're ready to move on then, okay? Next one is somewhat similar. It says the following rational equation has denominators that contain variables. Part A, we want to find the value or values of the variable that make a denominator 0. And then solve the equation, keeping those restrictions in mind. So over here, to find the values that make the denominator 0, first if I take 9x plus 27 and set it equal to 0, I get 9x equals negative 27. And dividing by 9, I get x equals negative 3. We look at that next denominator. To solve x plus 3 equals 0, I'd also get x equals negative 3. And looking at the last one, to say 9 equals 0 is just silly. 9 is never equal to 0. So the only value you'd exclude here is negative 3. Is everybody comfortable with that executive decision? If so, again, I like to get rid of the fractions. I know there are some people that get a common denominator and combine the fractions and then cross multiply and do all sorts of work. But I find it simpler if we can clear the fractions before we begin. To do that, we need that common denominator. To find the common denominator, I want to factor this first denominator. There's a common factor of 9, and that leaves me with x plus 3. So for that first fraction, I need 9 times x plus 3. Second fraction needs x plus 3, and it's there already. Third fraction needs 9, and it's there already. So that'll be my common denominator. Is everybody all right with that decision? And this is where I miss really being in a room with you folks, because then I could look up and see if you guys are in agreement or not. But I'm going to go on the assumption that silence means it's okay. So now I'm going to take both sides of that equation, put big parentheses around it, and multiply both sides by that common denominator. This time on the left-hand side, the denominator cancels, and I'm left with 7. On the right-hand side, I need to distribute, and so that would give me 3 over x plus 3 times 9 times x plus 3. And I'm going to put, that was a 3, by the way. Sorry. Put that over 1 minus 5 over 9 times 9 over x plus 3. And now here, the reason I do that is because each of the denominators should cancel. So I'm left with, on the left, 7. On the right, just 3 times 9 is 27. Minus, the 9s would cancel, 5 times x plus 3. Here we've got to distribute, and be very careful with your signs when you distribute. I'm distributing a negative 5. So that gives me 7 equals 27. Minus 5 times x is minus 5x. Minus 5 times 3 is minus 15. Oh boy, we've got some like terms. So let's combine those. That gives me 7 equals 12 minus 5x. Now to solve that, let's subtract the 12 from both sides, giving me negative 5 equals negative 5x. And then let's divide both sides by negative 5 to get x equals 1. So we're thinking that our solution is x equals 1. I'm going to go back to the original equation. You notice that that doesn't give me a 0 in the denominator. So hopefully this works. Let's see, we've got 7 over 9 times 1 plus 27 equals 3 over 1 plus 3 minus 5 over 9. 9 times 1 is 9, plus 27 is 36. So does 7/36 equal 3/4 minus 5/9? Common denominator would be 4 times 9, 36. So multiplying by 9, I get 27 over 36, minus multiplying by 4, I get 20 over 36. And so when I subtract, I do get that 7 over 36, and it checks. So our solution set is just that one number, negative 1. That one okay?
Yep.
Great. Next one is just asking us to solve a first degree equation. And I want to make you guys do a little bit of the work. So I'm going to shut up here for a minute and ask you folks to please distribute, simplify, and solve. Did anybody else? Well, did everybody finish or am I rushing you? Did anybody else get a solution to 7 and have the 7 check?
Yep.
Yep.
Great. I think the next 2 are word problems. The second one is quite wordy. The first one, not so bad. First one says the average cost of tuition and fees at a public 4-year colleges in the United States can be modeled by the following formula, where T represents the average cost of tuition and fees for the school year ending X years after 1996. When will tuition and fees at public colleges average $5,906? So this $5,906, we've got this equation T equals 165x plus 2,771. That 5,906. I'm thinking because we've got 2 variables in this equation, we've got to substitute for one of them. Should that be T or should that be X?
T.
So when we put that in for T, we get 5,906 equals 165x plus 2,771. And now that we have that equation, hopefully everybody's comfortable solving it. And so again, I'm going to shut up and give you guys a minute and ask you to solve it and see what you get. How are you folks still doing? Did anybody else get that x equals 19? You guys all right?
Yeah.
So is my final year, my answer 19?
Nope. We gotta
No.
add it to 1996.
Yeah, it's years after 1996. When I take 19 plus 1996, I get 2015. And now we're good. All right. Next one's a little involved. It involves 2 reductions. It says the price of a dress is reduced by 20%. Then when the dress still does not sell, it's reduced by 20% of the reduced price. If the price of the dress after both reductions is $320, what was the original price? Wow. Well, let's see what we need to know. We need to find the original price. So I'm going to let X equal the original. Then the first reduction is 20%, so 0.20 of that price. And so that first reduced price would be X minus 20% of X, which would leave me with 80% of X. But it's reduced by 20% of that. So that second reduction would be 20% of that sale price, which would give me 0.16x. And so when I take that off, the sale price, that's when I get that $320. This difference gives me 0.64x equals 320. Sorry about that. And so when I divide by 0.64, I get the original price was $500. That one takes a little bit of thought. How are you folks with it? Any questions? Should we go on to the next, or do we need to wait a minute?
Where does 0.80x come from?
Okay, I'm taking 20% off. And so it's the original price X minus the 20% of X. Are you okay there?
Yeah.
This X has a coefficient of 1. So if I were to take 1 minus 0.2, wouldn't I get 0.8?
Okay.
Okay, thank you for asking.
Thanks.
So in the same way here, when I take the 0.8 times the 0.16, that's when I get the 0.64. I think that's not difficult computation, but it's one that people frequently miss. Realize that your plain old X has a coefficient of 1. So when I take 1 minus 0.20, I do get 0.80. So we go on to the next problem then, which sounds harder, but I don't really think it is. But this one says that involves complex things. But again, remember, complex numbers just means that I'm going to have a plus bi form. I have to work with I. And before I read the words, well, even reading the words, it looks like this is a division problem. And so I need to take 2 plus 5i and divide it by 4 plus 2i. This is one of those ones where I really want to see the work, because if you paid enough for your calculator can do computation with complex numbers. And so you could probably just type it in that right calculator and get the answer. But that won't help you big picture if you're taking this course as a prerequisite to further math courses. So what we need to remember is, in order to get that I out of the denominator, can anybody remember what we had to multiply both the numerator and the denominator by?
Reciprocal of the denominator.
I think you know what you're saying, but just slightly wrong word. Instead of reciprocal, we're talking about conjugate, right? So same numbers, but if this is addition, the conjugate will have the subtraction. It's the opposite operation in the middle. Again, we use that conjugate pair. I'm going to do the easier half of this problem first to simplify the denominator, because it's the sum and the difference. It turns out to be the first term squared minus the second term squared. And so if I think of that as 16 minus 4i squared, just remember that I squared is negative 1. So that actually becomes 16 plus 4. And so our denominator is 20. We no longer have an I in the denominator. Kind of the equivalent of rationalizing the denominator. With the numerators, though, it's not that easy. They're not conjugates. So we have to multiply that out. To do that multiplication, I know some folks think of repeated distribution. I know there's some folks that draw a box each time. And I'm kind of old school, I FOIL. Either way, you should get that 2 times 4 is 8. 2 times minus 2i is minus 4i. 5 times 4i is 20i. And 5i times minus 2i is minus 10i squared. So here we have 8 minus 4i plus 20i is plus 16i. And then we have to remember that I squared is negative 1. So minus 10 times negative 1 would give me plus 10. And so I've got 18 plus 16i. But they want it in a plus bi form. They don't want a single fraction. They want me to split that up so that I have a real part, 18 over 20, and an imaginary part, 16 over 20 times I. And they want those fractions in lowest terms. So my final answer here would be 9 tenths plus 4 fifths I. And I know it says it's called complex, but it's really not that bad. We just need to remember that the product of the sum and difference is the difference of the squares. And we also have to remember that I squared equals negative 1. That's how it's defined. Any questions on that one? Shall we go on to the next problem? Everybody ready? Next one is a multiplication problem. And again, it works with complex numbers. Again, if we're squaring something, what we're doing is we're multiplying it by itself, which gives us first 4 times 4 is 16, plus 4 times 9i is 36i. Then we have another 9i times 4, which is 36i. Then we have 9i times 9i, which is 81i squared. Then we have to remember that I squared is negative 1. So this becomes 16 plus, let's see, we can combine those. That would give me 72i minus 81. And then 16 minus 81 would give me negative 65 plus 72i. How's that one? And again, the next one asks us to multiply two complex numbers. Then you have to either do repeated distribution or box or FOIL to get that product. And so I'm going to shut up for a minute and ask you guys to multiply that one. Did anybody else get 28 minus 64i?
Yep.
Great. Now, on the last quiz, I was a little bit more generous than I wanted to be. I'm not going to be generous at all this time on the test. If the test asks you to solve by factoring, you will not get credit if you do not factor. You need to be able to solve these quadratics using every possible method. And so if a question asks for you to use a specific method, you need to use that method. I did take some points off on the quiz, but on the test, I will not grade it if you do not use the method asked for. So over here where I have 16x squared plus 2x minus 3, I want to go ahead and try to factor that. And I'm thinking, let's see, 16x squared, if I use 8x and 2x, and that 3, if I use 3 times 1, if I make it negative 3 and positive 1, and again, I can start by factoring right away because that side is 0. I apologize, I forgot to make mention of that fact before we began. You can't factor until one side is 0. If I go through and check multiplying this out, 8x times 2x would give me 16x squared. 8x minus 6x would give me the 2x, and then I'd have the negative 3. And now that it's factored, does everybody remember, we're going to set each factor equal to 0. And when I solve those resulting equations, the first one would give me x equals 3/8, and the second one would give me x equals negative 1/2. Is everybody comfortable with the 3/8 and the negative 1/2? And again, you need to be able to factor. So if a question asks you to solve by factoring, you've got to solve by factoring. Next one asks you to, again, solve the quadratic by factoring. And so this time I'm going to be quiet and I'm going to ask you folks to factor. And again, you can start by doing that factoring right away because one side is 0. Was everybody all right factoring this one? Because it was a binomial, it turned out to be a much easier factor. You just had to find that common factor and then taking that out, setting both factors equal to 0 and solving. Could everybody get 0 and negative 5 as solutions? And again, they asked us to check, and so checking, they both worked. Any questions on that one? If not, the next one asks us to solve the quadratic by completing the square. We've got x squared plus 12x plus 7 equals 0. And move over so I have a little, well, I guess we'll start over here. X squared plus 12x plus 7 equals 0. In the questions on the quiz that involved this, they asked, what value do you need to add to both sides to make it a perfect square trinomial? Some people mistakenly said, well, the first thing I need to do is to move that 7 to the other side. So I'm going to add -7 to both sides. That would give me x squared plus 12x equals -7. But that's not what the question was asking for. The question was saying, okay, over here I've got this x squared plus 12x, leading coefficient 1, which is always imperative before we complete the square. We're saying, what do I have to add to make in here to make this a perfect square trinomial? And can you folks remember leading coefficient was 1, so we're going to look at that next coefficient, 12. We're going to divide it by 2 and square it. Well, 12 divided by 2 is 6, squared is 36. And so what we have to add to make a perfect square trinomial to both sides is 36. That'll give me x squared plus 12x plus 36 equals 29. Now, that is a perfect square trinomial. It becomes x. Since this is a plus sign, it'll be plus, and the number that I squared to get that was 6. So that's x plus 6 squared equals 29. Now we've got a quantity squared equaling a constant, so we can use that square root property. We can take the square root of both sides, but we have to remember that that constant side has two roots, a +1 and a -1. So that leaves me with x plus 6 can equal either the square root of 29 or x plus 6 can equal the negative square root of 29. And now subtracting 6 from both sides, we get x equals -6 plus the square root of 29, or subtracting here, we get x equals -6 minus the square root of 29. And so those would be my two solutions. Now that one's a little bit more involved than solving by factoring. But again, sometimes they don't factor. And this one would not have factored because it has an irrational solution. We've got that radical in our answer. Is everybody comfortable with this decision to add 36 to both sides? And then finish the equation using the square root property. Not hearing any questions, is it okay if we go on to the next one?
Yes.
Okay. Next one asks us to solve using the quadratic formula. I'll help you get started with this one. Does everybody remember to use the quadratic formula? We first want it in standard form, which is descending order, one side 0. To get that, we'd have to subtract the 4x and the 2 from both sides. So that gives me 9x squared minus 4x minus 2 equals 0. And now that's in standard form. We can say that a is the leading coefficient, b is the coefficient on that first degree term, c is the constant, and we'll substitute those into that quadratic formula, which is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to be quiet for a minute and ask you folks to do that substitution and tell me what you get. Did anybody else get one solution to be 2 plus the square root of 22 over 9, and the other solution to be 2 minus the square root of 22 over 9? How does my arithmetic look? Are you folks ending up in the same place or not? Any questions? Does anybody want any more detail? You guys all right? If so, next one asks you to again solve using the quadratic formula. This one's already in descending order, so you need to just identify A, B, C, and substitute. So why don't you folks go ahead and do that? And I'll wait a minute or two before I get started. How are you folks doing? Did you get 6 plus 3i and 6 minus 3i?
I did.
One thing on that last quiz that frightened me a little bit was that some people with something like this, when they got to the point of saying the square root of negative 36, told me that it does not exist. If we're only working with real numbers, it does not exist. But over here, if it says we can use I as needed, that means that we can take the square root of a negative. And so that'll be the square root of 36 times the square root of negative 1 or 6i. So be careful. I know in the past you might have been told, and I know in the past we even said that you can't take the square root of a negative number, but that's only if we restrict ourselves to the real world. We've got these complex numbers now. We can use our imaginations, and so we can now take the square root of a negative. There's no questions on this one. Let's look at the next. This one asks us to use factoring, but we have to realize that this one's much larger than a quadratic. It's fourth degree. And so remember we had said that if we have an exponent higher than 2, unless it's quadratic in nature, if we have an exponent higher than 2, we're going to make one side 0, which has been done for us already, and then factor. And so again, I'm going to ask you guys to do the lion's share of the work on this one. We've got one side 0. Go ahead and factor that 3x to the 4th minus 48x squared. And I'm going to make a strong suggestion that when you think of factoring, you think of factoring completely. Don't be thinking that you're done if you've only factored once. Did anybody else get 3 solutions of 0, -4, and 4? Does anybody have questions as to where those values came from? I'm going to add a little bit of detail. Over here, where 3x squared is equal to 0, dividing, I would get x squared equals 0. And that should actually give me x equals 0 or x equals 0. 0 is a solution twice because x squared is 0, but they tell you to type each one only once. So we'll only write our solutions as 0, -4, and 4. Next one, if there's no questions, the next one is a radical equation. And if MyLabs tells you to check, check. Because it means that that check is important. Can anybody remind me of what we had to do with this radical equation, the equation with the square root, if there is a variable underneath the square root, in order to get that variable out of the radical and solve it? Anybody remember?
Just raise both sides by 2.
The opposite of taking the square root is to square. So we're going to square both sides. Please be careful though. We cannot square both sides until that square root is all alone on one side of the equal sign. But since the square root is all alone on one side of the equal sign, we'll square both sides. And again, I want you to remember to be careful when we take that x plus 8 and square it. We need to think of taking that x plus 8 and multiplying it by itself. So when I square the radical, I just get the radicand, 6x plus 55. When I square that x plus 8, I'll get x squared plus 16x plus 64. And now we have a quadratic. We have a whole bunch of methods of solving the quadratic. I don't think we're going to start by using the square root property. So let me go ahead and put it in standard form, making one side 0. Give me a second, guys. I just want to make sure that I did. Yes, let him out of the waiting room. I'm sorry. So that gives me 0 equals x squared plus 10x minus 9. I apologize. That shouldn't be minus 9. That should be a plus 9. I think that's pretty factorable. If I factor my 9 into 1 times 9, and when I set each factor equal to 0, I get x can be -1 or x can be -9. But again, I want to check those in the original. The original was the square root of 6x plus 55 equals x plus 8. First, if I check x equals -1, that's the square root of 6 times -1 plus 55 equals -1 plus 8. That gives me this principal root of 49 is 7, and it checks. If I put in the -9, that gives me the square root of 6 times -9 plus 55 equals -9 plus 8. That gives me the principal square root of 1 is -1. And because there's no plus or minus in front, this just means the positive one. And so this one we're going to reject. And so our sole solution is going to be that x equals -1. Is everybody all right with that one? Any questions? You ready for the next problem? Next problem asks me to solve this equation with rational exponents. And again, remember, if I have a rational exponent, if I have a fraction in the exponent, we want to get that part with the rational exponent alone on one side of the equal sign. And then, can anybody remember what we had to do to both sides of the equation to clear that fractional exponent?
You raise to the reciprocal.
Beautiful. So the reciprocal of 5/2 is 2/5. So we're going to raise both sides to the 2/5 power. The reason we use the reciprocal is because when we raise a power to a power, we multiply exponents. And when we multiply something by its reciprocal, we get 1. So that just gives me x minus 6. On the other side, I know some people evaluate expressions like that using a calculator, By hand, does everybody remember that if my exponent is a fraction, I'm going to have a radical? My radicand is going to be that base. That denominator becomes the index of the radical, and that numerator becomes an exponent. Well, the fifth root of 32 is 2. Squared is 4. So that gives me x minus 6 equals 4. And now that's pretty easy to solve. When I add the 6, I get x equals 10. So let's go ahead and do the check. Does 10 minus 6 to the 5 halves equal 32? Well, 10 minus 6 is 4 to the 5 halves, would mean I'm taking the square root, the second root of 4, and raising it to the 5th power. And 2 to the 5th is 32, and it checks. That one okay? Not hearing any questions? The next one asks us to solve the absolute value equation, or say that it has no solutions. When I look at an absolute value equation, I notice that it has 2 bars. And the fact that it has 2 bars reminds me that what I need to do here is solve 2 different equations. Again, with absolute value, sometimes my sign stays the same, and sometimes my sign changes. And so I think, okay, for my one equation, I'm going to just lift those bars, and it stays the same. And for the other, I'm going to lift those bars and change the sign on the opposite side. Remember, we're going to change the sign on that opposite side. This gives me 2 pretty straightforward equations to solve. Adding 1, I get 2x equals 4, and dividing by 2, I get x equals 2. x1, adding 1, I get 2x equals negative 2. And dividing by 2, I get x equals negative 1. Because they give you the possibility of having no solutions, I would check this. And so checking, does the absolute value of 2 times 2 minus 1 equal 3? Well, that's 4 minus 1, or the absolute value of 3 equals 3, and it checks. And then let's see, does the absolute value of 2 times negative 1 minus 1 equal 3? Well, that's negative 2 minus 1, or the absolute value of negative 3 equals 3. So it also checks. So I do have 2 solutions, and there are the numbers 2 and negative 1. That one okay? Not hearing any complaints. Next, we're asked to find the intersection or overlap between 2 intervals. They ask us to do it using graphs. I think in my labs, this might have a multiple choice part to it. First, I've got the open interval from -3 to 6. So I'm not including my -3, and I'm not including my 6. My second one, I've got the closed interval from -2 to 9. And so here I am including -2, and I am including 9. When I look for the intersection, I look for where they overlap. And so what they both have in common are the values from -2 to 6. Here, because I've got a squared bracket, I'm including the -2. Here, because there's no break, I'm including the -2. So I won't include the I will include the -2, I apologize. Here, because I have that rounded bracket, I'm not including the 6. So the intersection won't include the 6. And so my solution would be the values from -2 to 6, including the -2, not including the 6. Is that one all right? Not hearing any questions. I'm going to go on to the next problem. Does anybody need more time with this one?
No, I understand that one.
Okay. Next one asks us to do those graphs again, but this time we're finding the union. And when we take the union, we're just combining the two, putting them together. So the first one goes from -4 to +infinity. So we're including that -4 and all of the values to its right. Next one asks us to not include 1, but we want everything to the right of 1. And now when we take the union, we're putting the two together, we're combining them. And so the furthest to the left that I go is my -4, and both of them continue infinitely in the positive direction. And so my union here would be -4 to infinity, closed at -4, open at infinity. Because again, when I take the union, I'm just putting the two together. When I take the intersection, I'm just looking for where do they overlap. If that's all right. Next question asks us to solve a linear inequality and choose the right solution from the number line graphs below. They want us to type our solutions in interval notation. And we've got 6 times x plus 1 plus 4 is greater than or equal to 5x plus 17. Again, solving these inequalities is real similar to solving an equation. Just remember, you need to be careful if you multiply or divide by a negative number. And so I'm going to be quiet for a minute and ask you folks to work on this one. Did anybody else get that x is greater than or equal to 7, or the interval closed at 7 to infinity, and that C was the correct choice? This is one of the ones where, again, I think I've said repeatedly during the course of the semester, I need to see your work. And the reason that I need to to see your work is if you went through and you did a careless mistake here and you hid the wrong inequality. Well, if you hit the wrong inequality, there's no way in hell you pick the right number line graph. And so with questions like this, if your number line graph corresponds to your answer, I will give you the partial credit for graphing it correctly, because the only thing that you could graph is what you got. Again, though, I do need to see work for these, because I know there are apps out there that if you just take a picture of the problem, it gives you the solution. And I don't want you to be able to do that. I want you to be able to solve the equations. I don't think anybody's kind of taken this class just because they want to. It's a prerequisite for something. If it's for entry into your program, there are skills here that they feel you need for your program. If it's a prerequisite for the next class that you need to take, then everything that we're doing here is something that you need to be able to do for that next class. So make sure you show me your work. And oh my heavens, is that the last one? I guess so. Any questions? I would strongly suggest that you go through and you do this problem set at least 2, if not 3 times before you take the test, because the problem set, some of the questions are, it's called pooled, where question 22 might be linked to not just one question where the numbers change for people, but it might be linked to 2 or 3 similar questions. And so your inequality might be different. For example, somebody might have gotten a compound inequality here instead of a single inequality. So again, well, these are the ones that the iteration that I got of the problem set when I printed it and inserted it into OneNote last night. Next time you do it, the problems might look different. The word problems might be different, and so on. Does anybody have questions on any of these? Does anybody want to look at any more of these problems? Or does anybody want to look at anything at all from any of the homework?
This may kind of, yeah. Can you describe what the brackets mean again? Like the square versus the round?
Sure. I'm going to go up and open a page. You know how you've got less than, greater than, less than or equal to, greater than or equal to. And are you comfortable with the differences between those symbols?
Yes, I am.
Okay. Then strictly less than, strictly greater than are those rounded brackets. Less than or equal to, greater than or equal to are those squared brackets. So for example, I'm going to pick a random, let's say I have -2 is less than x is less than or equal to 7. If I were to do this on a number line, I know I'm looking at values between -2 and 7. I'm not including the -2. I am including the 7, and I want everything in between. And are you okay with the open dot, meaning I'm getting close to that number, but I'm not including it? The closed dot, the colored in dot, meaning, yeah, I want to include that 7. Well, at some point in time, instead of coloring in dots, they get changed to parentheses. The open dot is like this rounded one, saying I'm going all the way up to it, but not including it on mountains and back. The squared one is like the closed dot, saying that I am including that. And so I would say that the smallest value is -2, the largest value is 7. I can't equal -2, I can equal 7. And so this interval means exactly the same as that original inequality, -2 is less than x is less than or equal to 7. Does that help?
Yeah, helped a lot. Thank you.
You're welcome. Anybody else have questions on anything else?
Is there homework due today?
There's a lot of homework that is due on Friday. If you look, today is the 18th. Oops, I take that back. I might have written that wrong at the beginning of the notes. Let me double check. Yeah, no, homework 1.6 is due today. Those involve those other equations.
Hmm.
And homework 1.7 is due on Tuesday. Those is the problem set. Those involve inequalities and review for the test. The test 2 is in my labs. You're going to submit pictures of your work in Blackboard. It'll be open starting tomorrow until end of the day, Wednesday. We're opening it early because we finished early and some people wanted the weekend to work on it. And we're including Tuesday and Wednesday because some people were looking forward to that extra time to study. However, please realize that in class on the 23rd, we might field questions on those assignments, but otherwise on the 23rd, we're going to start that next section. So let me go through and just double check the test. Oh, I don't have it assigned yet right now. It's opening. Wait a minute, that's today. It wasn't supposed to open until tomorrow. Until at 11. Let me go through and change that. That settings. Oh, and how early in the morning did you folks want to be able to work on that test tomorrow? Those of you who wanted to start early. Tomorrow is something, whoops, is something crazy like 8 o'clock in the morning early enough, or would anybody be starting it earlier than that?
That's good for me.
Okay. Then let's go
Thank
through
Thank you.
and save that setting. And assign it. And again, some folks need extra time. That pop-up that I just saw said that the extra time was in there for you. Does anybody want to look at any homework problems? If not, this was all I had scheduled to do today. If nobody wants to look at any more problems, if you folks are okay, all right with it, we could end class early. I don't think that we've really done that yet. Or if you have more questions, please make use of your time now and ask them. I'm not a mind reader. And if you don't ask questions and something's not clear, usually what happens is I don't find out until it's too late, until I grade a paper. Any questions? Did you guys want to call it a day? Does anybody mind if we end class early? I know a couple people came in late. Let me go through it and make sure I've got them. Joey, we've got you.
Joey is in me or Pellegrino?
I've got both of you.
Okay, thank you.
All right. And Alyssa, I got you. Kyler, I got you. I don't think there was anybody else who came in after I took attendance. Is there anybody else who came in that didn't hear me call them and roll? If not, shall we call it a day?
I think so. I don't know,
Okay.
maybe.
All right.